Let us proceed with 14.3 thermodynamic works. Okay, lesson 18, learning outcomes. And for 14.3 thermodynamic works, discuss work done in isothermal, isochoric and isobaric process. For B, solve problem related to work done in isothermal process, isobaric process and isochoric process. Okay, now consider a gas of fixed mass in a cylinder with a frictionless piston of a cross-sectional area A as shown in figure below. Okay, suppose the gas expand infinitesimally at a constant pressure P. The force exerted by the gas or system on the piston is given by F equals to PA. Okay, the work dW done by the gas is given by dW equals to F dx cos theta, where theta equals to 0 degree and F equals to PA. Okay, now we substitute F with PA. So our equation become dW equals to PA dx. And we know that when area times dx equals to dV. Okay, so we substitute A dx with dV. So now our equation become dW equals to P dV. In the finite change of volume from V1 to V2, okay, we integrate dW and from 0 to W, okay, equals to integration of P dV from V1 to V2. So integration of dW, we get W. Okay, so W equals to integrate from V1 to V2 and integrate P dV from V1 to V2, where W is work done, P is pressure, V1 is initial volume of the gas and V2 is final volume of the gas. Look at this slide. Okay, the work done in isothermal process. From the equation of state for an ideal gas, PV equals to nRT, then PV equals to nRT over V. Therefore, the work done in isothermal process with change of volume from V1 to V2 is given by W equals to integrate PdV from V1 to V2. Okay, so P we substitute with nRT over V. Okay, so nRT is constant, so we put out of the bracket. So now we just need to integrate 1 over V dV. Integrate 1 over V and we get ln V. So substitute, okay, from V1 to V2. So now our equation become W equals to nRT ln V2 over V1. So this is the work done in isothermal process. Okay, isothermal process, temperature is constant. So this is Boyle's law. Remember, and we have triangle P, V, T. So when temperature is constant, so we have PV equals to constant. So we have equation P1 V1 equals to P2 V2. Rearrange this equation. Okay, so we make as a ratio V2 over V1 equals to P1 over V2. Okay, from the previous equation, okay, we have W equals to nRT ln V2 over V1. We also can write W equals to nRT ln P1 over P2. Okay, from the first law of thermodynamics, Q equals to delta U plus W, and for during isothermal, okay, delta U equals to 0 and internal energy is equals to 0 when temperature constant. So Q equals to W. Okay, from the previous we have equation for the work done. W equals to nRT ln V2 over V1. So if W equals to Q, so we also can write Q equals to nRT ln V2 over V1 or nRT ln P1 over P2. Okay, which is equals to work done, okay, during isothermal process. Okay, next we go to the work done in isobaric process. The work done during the isobaric process, which change of volume from V1 to V2. Okay, so W is equals to integration PdV from V1 to V2. During isobaric process, pressure is constant. Okay, so now we just need to integrate dV. So integrate from V1 to V2. So we substitute value, integrate dV, we get V. Okay, integrate P dV. So we get P times V from V1 to V2. So substitute V2 minus V1. So we have the work done during isobaric process, W equals to P delta V, where V final minus V initial. Now look at this slide. Okay, we have P pressure against volume graph. Okay, so we know that to calculate the work done, and the work done is equals to area under the graph, pressure against volume graph. Okay, look at the first graph, okay, which is in isothermal expansion. Okay, means the volume is expand. Okay, look at V1 expand to V2. Isothermal temperature constant. So the relationship between pressure and volume is inversely proportional. Okay, look at during V1, our pressure is P1. Okay, so what happened when pressure decrease, our pressure is decreasing to P2, the volume is expand. So our work done is positive. Okay, so equation for the work done, W equals to nRT ln V2 over V1. Okay, what happened during isothermal compression? Okay, during isothermal compression, okay, the volume is decreasing from V1 to V2, and the volume is decreasing and pressure is increased. Okay, so during isothermal compression, okay, we also can use formula W equals to nRT ln P1 over P2, depend on value given. Okay, so for the work done during isothermal compression, the work done is negative. Okay, next we go to the isobaric expansion. Okay, isobaric expansion, pressure is constant. Okay, pressure constant. Okay, look at the graph. Volume is increasing, increase from V1 to V2. So during isobaric expansion, the work done is positive. Okay, next in isochoric, what is isochoric? Volume is constant. Okay, so area under the graph is equals to 0 during isochoric process. So look at this graph, and the area under the graph equals to 0, therefore work done also equals to 0. Okay, we have 4 process: isothermal, isochoric, isobaric, and adiabatic. Okay, look at isothermal. Okay, refer to the graph path AB. Okay, refer to the graph path A to path B. Okay, what happened? Okay, during isothermal, okay, a process occur at constant temperature. Okay, A and B is in the same line. Okay, during isothermal, the internal energy is 0 because temperature constant, and the change in internal energy is 0 because temperature constant. So what happened to our first law of thermodynamics? Remember first law of thermodynamics here. First law of thermodynamics plot Q equals to delta U plus W. So if the change in internal energy is 0, therefore our heat is equals to W. So negative Q equals to negative W. If work done positive, mean Q also positive. So we can write equation for the work done, W equals to nRT ln P1 over P2, or W equals to nRT ln V2 over V1. If Q equals to W, so we can write our equation Q equals to nRT ln P1 over P2, or Q equals to nRT ln V2 over V1. For isothermal, which is Boyle's law. So PV is equals to constant, or we can write P1 V1 equals to P2 V2. Next we go to the isochoric, which is path A to D. Isochoric, volume constant. A process occur at constant volume, so the work done is equals to 0 because volume is constant. So what happened to Q? Q equals to delta U because W equals to 0. From the first law of thermodynamics, Q equals to delta U plus W. W 0. So Q equals to change in internal energy. If change in internal energy negative, so our Q become negative. During a volume, constant volume, we have triangle PVT, volume constant, which is Gay-Lussac law. So we have equation P over T equals to constant. So we can write equation P1 over T1 equals to P2 over T2. Next we go to the isobaric. Isobaric path A to E. A to E, where pressure is constant. So delta P equals to 0. So we have from the first law of thermodynamics, Q equals to delta U plus W. So if the work done is negative, internal energy negative, so our Q also negative. So W equals to P delta V. How to calculate work done? So for isobaric, for isobaric PVT, pressure constant. So this is Charles' law. So V over T equals to constant. So we can write equation V1 over T1 equals to V2 over T2. Next we go to the last one, adiabatic. Path A to C. From A to C, pressure change, volume change, and temperature change. A process occur without or no heat transfer into or out of the system. There is no heat in or heat out of the system. And the process occur without or no heat transfer into or out of the system. During adiabatic, Q equals to 0. So if W negative, the internal energy is positive. If the work done is positive, and the change in internal energy negative. Remember what is mean by W positive, work done, and W positive mean the work done by the system. W negative, the work done on the system. So that's all for chapter 14. Thank you.